For 70 years, we've had a dream to make machines think. But this dream wasn't built in a day. It was built term by term, idea by idea. Today, we're explaining every single one. No filler, just the story of how we taught code to learn. Let's start. It all begins with this term, artificial intelligence. In 1956, a group of scientists gathered at Dartmouth College. Their leader, John McCarthy, wasn't just coining a phrase, he was making a bold proposal. He believed every part of human learning could, in theory, be simulated by a machine. That conference was the big bang of AI. The goal wasn't just a calculator, it was a thinking partner, a chess AI that doesn't just follow rules, but strategizes. Okay, so AI is the goal, but how do you do it? For decades, we tried to hard code rules. If this, then that. It failed. The world is too complex. This led to the AI winter, a time when funding dried up and progress stalled. The solution was a new idea, machine learning. Championed by Arthur Samuel in 1959, the concept was radical. What if we stopped telling the machine the rules and instead let it figure them out? He built a checkers program that learned by playing itself, eventually becoming better than he was. It wasn't programmed to be good, it learned to be good. That's the key. Your spam filter is a perfect example. No one programmed it with "buy this" as a rule. It learned what spam looks like from millions of examples. But for a machine to learn, it needs a textbook. This is a dataset. For a long time, datasets were small and boring. Then in 2009, Dr. Fei Li had a vision. She and her team created ImageNet. They didn't just gather a few thousand images. They gathered 14 million labeled images. Critics thought it was too big, too expensive. But she knew that to learn about the real world, the AI needed to see the real world. ImageNet was the fuel that lit the fire of modern AI. The dataset is the what. The algorithm is the how. An algorithm is just the step-by-step recipe the machine follows. The process of feeding the ImageNet dataset to the algorithm is called training. This is the study phase. You show the algorithm a picture of a cat, it guesses dog. You say wrong. You show it another, it guesses cat. You say right. Now multiply that by 14 million. That is training. After training, you need the final exam. This is testing. You show the AI a new picture of a cat it has never seen before. If it gets it right, it has truly learned, not just memorized. So what's the best algorithm for learning from data? For decades, a few researchers, now called the godfathers of AI, Geoffrey Hinton, Yann LeCun, and Yoshua Bengio, worked on an idea everyone else thought was a dead end: neural networks. It's an algorithm loosely modeled on the human brain with digital neurons in layers. For a long time, their work was ignored. But in 2012, Hinton's team unveiled AlexNet. It was a deep neural network trained on ImageNet. It crushed the competition in an image recognition contest. It wasn't just better, it was a revolution. This one moment proved that neural networks were the future. Your phone's facial recognition? That's its direct descendant. Now that cat and dog training, that's called supervised learning. It's supervised because every image was pre-labeled. You're the teacher giving the AI all the answers. But what if you don't have the answers? That's unsupervised learning. You give the AI a mountain of unlabeled data and just one instruction: find the patterns. It's like telling a marketing AI to segment these 10 million customers, and it discovers 5 new types of shoppers you never knew existed. How does the AI actually learn it's wrong? It uses a loss function. This is simply a piece of math that acts as a scorekeeper. When the AI guesses dog, but the label is cat, the loss function screams, "You were 80% wrong." The goal of training is to get this wrongness score to 0. And how does it fix the error? With a brilliant algorithm called backpropagation. This was the key that unlocked neural nets, championed by Hinton and others in 1986. It sends that 80% error signal backward through the network, telling every single neuron, you contributed 0.2% to this mistake. Tweak your connection. After millions of these tiny tweaks, the network is accurate. It has learned. Neural nets conquered images. But text was harder. Language is all about context. And in 2017, everything changed. A team at Google Brain released a paper. It had a simple, audacious title, Attention is All You Need. This paper introduced the transformer. It was a new kind of neural network that was masterful at understanding context. It is not an exaggeration to say this one paper is the foundation of the entire modern AI boom. Why? Because of what was inside it. Attention is the secret sauce inside the transformer. It's a mechanism that lets the model pay attention to the right words. In the sentence, the animal didn't cross the street because it was too tired. Previous models would get lost. But an attention mechanism can look back and know with 99% certainty that it refers to the animal, not the street. This ability to weigh the importance of words is how AI finally understood language. But how does an AI read a word like animal? It can't. AI only understands math. The solution is embeddings. This is a process that turns a concept, a word, a sound, even a pixel, into a long list of numbers, a vector. It's like a coordinate system for meaning. In this system, the coordinates for king and queen are incredibly close, but the coordinates for king and car are miles apart. Embeddings are how AI performs math on meaning. So we have AI for text. What about those incredible AI images? They're made by diffusion models. The idea is pure creative genius. First, you train a model by destroying images. You take a photo of a cat and you add a little bit of noise, then more, until it's pure static. You train the AI to reverse this process, to denoise the static, step by step, back into the original image. Once it's trained, you can give it new static and a text prompt like a photo of a cat wearing a hat. The AI will denoise that static into the image you described. That's DALLE, mid-journey, in stable diffusion. It's not finding pictures, it's dreaming them from noise. Finally, you put it all together. You take the transformer architecture, you feed it embeddings from literally half the internet, and you make it massive. The result is a large language model, or LLM, GPT-4, Claude, Llama. These are LLMs. Their one simple job is to predict the next most likely word in a sequence. But it turns out when you get really good at predicting the next word, you're not just rhyming. You're summarizing, translating, coding, and reasoning. You are, in effect, learning, which brings us to the end of our story. For now, Artificial General Intelligence, or AGI. This is the dream from 1956, a single system that can learn, reason, and generalize across any task just like a human, or better. We are not there. Everything we have today, from ChatGPT to Midjourney, is narrow AI. It's an expert at one thing. A GI is the hypothetical expert at everything. It is the final and most controversial chapter in this story. So from a 1956 conference to a 2017 paper, from a checkers program to a model that dreams, AI isn't magic, it's a story. A chain of brilliant ideas built one on top of the other by people who believed machines could learn. Understanding these terms is the foundation for understanding and building the future.